Okay, so a little while ago, a friend of mine lent me a set of the Winspace Hyper Wheels. Now I'm still running rim brake on my bikes. That's a whole nother debate. Let's just not go there at the moment. But yeah, so I borrowed these the Winspace Hypers. He said, try these out. See what you think. So I put them on the bike and I took them for a ride in a whole bunch of different conditions. And I also did a bunch of testing on them in terms of lateral stiffness. So I've got a big database of a whole bunch of wheels, like for probably a couple of hundred, well over a couple of hundred wheels. In lateral stiffness and also in some torsional stiffness and all that sort of stuff. So I'll show you some of that data as well. I also had some spokes, some of the carbon spokes that are used. So there were a couple of spares that were donated to me. So I put them in my my mechanical, basically tensile tester machine that I've built, and tested the ultimate tensile strength of the spokes, and I'll show you that, and I'll also compare the tensile strength to a SAPM CX-ray spoke, and also a titanium spoke. So you can see the different mechanical properties, so talking stiffness and tensile strength of that. But first of all, let's go to my ride impressions. So yeah, they feel fast. They definitely feel fast, and the handling of them in crosswind conditions was also excellent. So there's a local loop. Anyone in Melbourne will know the Kew Boulevard. Anyway, sort of up and down, round and about. It's got some corners. Often gets windy. Sort of there's a bit of a hill there. On top of the hill, it gets windy. A couple of high-speed sections where where you can get a bit of crosswind. So yeah, took them around there. The handling in the wind was excellent. So they were very impressive to ride. One of the issues, and it sort of depends. I mean, you can call it an issue. It can be a strength and a weakness, and that was the stiffness of the wheel. So as I'll show you later in the video, there's the lateral stiffness of these wheels is off the charts. Like they are really stiff laterally. So how does that transfer into ride quality? Well, basically it's a really stiff wheel, and so in some circumstances, in my opinion, I think they're too stiff. So and by that I mean that the ride quality actually suffers a little bit. So like on smooth, even, fast bitumen, very fast. No issues with that. On the bumpy stuff, if the road's a little bit lumpy, the wheel tends to skip a little bit and break traction, where I think a slightly less stiff wheel will give you a little bit more traction in those sort of situations. So anyway, that's let's go and have a look at the lateral stiffness test, and you can see the numbers there, and yeah, and then we'll talk through some of the other advantages and disadvantages and things like that of these wheels. So here's the test rig. It's basically a heavy steel frame, and it's very rigid, so yeah, it doesn't move. The wheel gets mounted within the frame. It has, in this case, it's the through axle, which gets locked in place with tapered cones. So again, that locks in and cannot move. Then we have a 20 kilo weight plate, which you can see on the right hand side there. That then transfers the load to the rim through that push rod with the nylon bushing on it so the rim doesn't get damaged. We then measure the deflection with a digital dial indicator, and that's about it. It's we log the data from that, and we've done hundreds and hundreds of different sort of tests on this stuff. So I've sped up the footage on this just because you don't need to see it in real time. Basically, we preload the rim and then zero the dial indicator and then take the weight off and measure what the deflection is. We do it in 4 areas around the rim. Often you'll be surprised there'll be differences in stiffness in different segments of the rim. So here's a data table. I've separated it into front wheels and rear wheels. You can see the lightweight Shimano, a couple of different Shimano ones, the 7900 series and the 9000 series in the C50s, a Zip 404, an NB SES, a Shimano Ultra Gold. So they're all sort of about a similar sort of depth rim and a similar sort of performance level. And then I've thrown in an old school Ambrosio Elite with a Dura-Ace hub, 36 plain gauge spokes. So that's with 36 spokes, that's a really stiff wheel, like an old school type wheel with box section rim. And as you can see, the stiffness is comparable to the Winspace, and the Winspace is significantly stiffer than everything else in the front wheel. So looking at the rear wheels, again, similar sort of trend. The only thing you'll notice, well, not the only thing, but one of the things you'll notice is there's quite a big difference between the earlier 7900 series Dura-Ace C50 and the 9000 series Dura-Ace C50. So the newer model is significantly stiffer. The other thing to notice is that the non-drive side and the drive side are usually different. They have a difference in stiffness due to the bracing angle, where the Shimanos are really well balanced for that. They're almost symmetrical, whereas others have a bit more variability in that. And but the Winspace wheel is comparable to the Zip flat disc wheel. So everybody knows how stiff a full disc wheel is, and the Winspace is sort of comparable to that. So that gives you a good indication on how it rides. So let's go to the spoke. Let's have a closer look at the spoke. So what I've done is I've put them in the tensile tester rig that I've got. So it's basically a ball screw which applies force through a load cell. I'm measuring the displacement with a linear position sensor and the force with the load cell, all going into a data acquisition system. So I've tested a whole bunch of spokes over the years, and also done rim pull-through testing, like spoke pull-through testing, to see how strong that interface is on rims and things like that. So one of the things that I was really sort of uncertain of was the failure mode of these spokes. So, but let's have a look at some of the testing and have a look at those results compared to a CX ray and also a titanium spoke, and then we can get a bit more of an understanding of why the wheel is so stiff. So here's the basic rig. You can see the ball screw there and the load cell and the position sensor. We've got a display module which is coming into the picture there. The spoke is mounted in steel bracket and pulled until it breaks effectively. Okay, so let's put the load on this spoke and see what happens. So you can see the equivalent kilogram load force ramping up there, coming up to 100. So just as a guide, like a CX ray typically fails at around 310 kilos, thereabouts. That's pretty standard for most metal spokes. They fail around that 300 odd kilos. So let's see where this one goes to. Okay, well, there's 310, 320, 350, still going. Coming up to 400 now. 400, and keeps on going, and bang, there we go. What was that, around 420? So the thing to note was that the spoke actually failed at the bond at the hub bonded piece that attaches where the hub attaches to the spoke. So the actual spoke itself didn't fail. It was the bond interface that failed. So here are the results between the Hyper carbon spoke, which is in blue, a CX ray, which is in orange, and a titanium, Maui titanium aero bladed spoke that I tested ages ago. So you can clearly see the difference in stiffness. So basically, the steeper the line, the stiffer it is. So the carbon spoke is significantly stiffer than the CX ray and the titanium, which are quite comparable. The titanium and the CX ray are quite similar. The titanium is probably a little bit flatter, a little bit less stiff, and not quite as strong either. So, but you can see a clear advantage in terms of stiffness with the carbon spoke, and also in strength too. But the downside is less elongation, which we'll come to in a minute. Okay, so what we're doing here is loading up the spoke, and then we're going to impact it with a side load, just with a 12-inch ruler or 30 centimetre steel ruler, and we're going to hit it on the edge like this. So it's under 120 kilos of tension there, which is typically what the wheel will be built at, thereabouts. And so we impacted it. Let's take it up a bit higher. You can hear the change in tone. We'll take it up a bit higher still, and we'll hit it again. Basically, I was expecting the whole spoke to shatter at this point in time, and didn't do that. So that was quite impressive, actually. I'm hitting it quite hard with a fairly small surface area steel edge. We'll take it up a bit more, and we'll do it again. But I was really expecting it to let go with that, and it didn't. So that's a positive. And this is a static test. You really need to do a dynamic, like a more dynamic test. So that may expose a different failure mode. So overall, how do I rate these wheels? And that's a good question, because it's one of those things which I'll just say, and this is a typical engineering response, is it depends. So it depends on the sort of riding that you do. If you're riding on smooth bitumen, racing type situation, they feel great. The one big concern I have, and I need to actually do more testing on this to actually look at the mechanism, the failure mechanism. But what the real concern I have is the failure mode of the spokes, and this is something that nobody has discussed on these carbon spoked wheels. And as we saw in that, when I was hitting the spoke with the side of the ruler under tension, it survived that no problem, and I really thought it was going to fail and fail catastrophically in that load case, but it didn't. So that was a little bit reassuring, actually, I have to say. However, I've had quite a number of failures come through the workshop, and even like coroner's reports where the riders died, and really bad accidents where a stick or something has flicked up off the road, gone into the spokes, and impacted against either the seat stay or chain stay or the fork blades, and led to the wheel failing. So now, with a metal spoke like a CX Ray or any of the metal spokes, you get what's called elongation. The spoke will stretch. Often you'll see the spokes will be distorted in shape. They'll be bent. And depending on the rim, the spoke nipple will pull through the rim. That sort of thing happens. But you won't get a situation where you'll lose all the spokes all at once due to a brittle type failure. That's extremely rare. And so I don't know, people, if you go back, there was the Mavic RSys wheel, which had a number of catastrophic failures where basically all the spokes just let go, and you had nothing. And they were a carbon tubular spoke. It was then revised where they put a bundle of Kevlar fibers within the tubular carbon spoke to try and provide a bit more toughness to prevent that sort of catastrophic failure mode. The other thing to be mindful of is with the Uci Wheel Test, that was introduced because wheels were failing catastrophically in this sort of type of situation. So it started off, there was the spinages where spokes were just exploding. And then lightweights, it was at the Tour de France where a rider crashed into a dog that ran out and the wheel just disintegrated. And then so that prompted the UCI to do this wheel testing to try and reduce these catastrophic type failures of wheels. Now, it's quite a difficult thing to test, so more work sort of needs to be done in this area. But with a spinning wheel, with carbon spokes, and if you throw something in as like a stick would pick up and get snagged into between the frame and the wheel and the spoke, would you take out all the spokes? How many spokes would be left? Obviously it depends how fast you're going and all these sorts of variables, so it makes it quite tricky to test. But that's still my one concern with all of the carbon spoked wheels out there. So the original lightweights had Kevlar in the spokes as well. The current ones don't, but they are quite a thick spoke on the lightweights. There are other carbon spoked wheels out there in the market. Some new players have come into the market. How do they perform under this catastrophic sort of load condition? So that's my one concern, is just the failure mode due to such low elongation of these carbon spokes. And usually you don't have many spokes, so there might only be 16 spokes with this high, this low elongation, and then this fracture critical failure mode. So that's my one concern with these wheels. Apart from that, on smooth surfaces they ride really well. If you're a light rider, you'll probably find they could be too stiff for you. Like you might get thrown around a little bit, much particularly on a bumpy road. You might be losing traction. Aerodynamically, they appear to be fantastic. So anyway, we'll leave it at that. I've spoken long enough. I'd love to hear your comments and any experiences you've had with carbon spokes and failures of carbon spokes. As usual, put the comments down below, and we'll see you again soon. Okay, bye. One more thing, I almost forgot. One thing that really actually annoyed me on these wheels, and I really hate noisy bikes, noisy wheels, noisy stuff. Like, I really hate that stuff. There was this noise when you accelerated, when you jumped out of the saddle and accelerated, from the back wheel, from the spokes rubbing against each other. Now, because the way the wheel was laced, the spokes were basically, on the cross, obviously not an issue on a radial because they're not going to touch each other, but on the rear wheel where they were crossing each other, the spokes would rub and have this little squeaky sort of noise under power, and that was really annoying. You could put a little bit of wax or something, some other lube there to stop that, and that it was effective in reducing the noise. In the long term, with that rubbing, you might get a bit of fretting and you might get a bit of wear, that sort of stuff happening. So an ideal, it'd be much better to have a bit of a gap so that the spokes weren't touching, or you could put maybe a piece of Teflon tape or something like that over that at that junction. But that was really annoying. So almost forgot that. I don't know what I was thinking. Hate noise. Hate noisy wheels. So apparently they are trying to rectify that. They are aware of that issue. So I don't know if the current ones are still doing that, but again, it's I don't know if anyone else has been talking about that, but didn't like that aspect of it. But with a bit of it's like without the noise. So once I lubed it, it was much better. But don't like noisy wheels.